Hi everyone, we're back and we're going to work on examples solving inequalities. This video is way more procedural than the other ones where we were looking at real life application, and in this one I'm just going to focus on the process of solving an inequality over and over and over again. So if you feel like you understand how to do this, go ahead and just pause the video and see if you can solve these inequalities on your own first, and then you can watch this tutorial as like a check to see if you got any of them wrong, and if you did, how to fix it. Let's get started. Example 1 has a negative 3/7 x minus 5 less than or equal to 2.5. Notice that we have fractions, whole numbers, and decimals mixed together. So I'm going to go ahead and rewrite this in all fraction form. So I converted that 2.5 to a 5 halves, and then I can look at that whole inequality and I can see that a 7 and a 2, and technically the 5 has a 1 as a denominator. My LCD, my least common denominator, would be 14. And so I can multiply both sides of this inequality by 14 to clear my fractions. You can also think of it as 14 over 1. When I multiply that through, I'll have 14 over 1 times the first fraction minus 14 over 1 times 5 firsts, or 5 over 1, less than or equal to 14 over 1 times 5 halves. Now, should I do this every time? I do it in my head every time, but I don't necessarily need to multiply 14 over 1 every time I clear fractions on an equation or an inequality. But this is a way to do it in your head, and so that's why I'm showing you my process. 7 and 14 divide, and I'm left with 2 over 1, and then 2 is in the numerator over 1. 14 over 1 times 5 over 1, that's just a straight multiplication in the numerator. And the 14 and the 2 divide, and I'm left with 7 in the numerator and 1 in the denominator. Let's go ahead and rewrite this. This is an equivalent inequality where we have 2 times negative 3x, so that would be negative 6x. 14 times 5 will be 70, and it'll be negative, less than or equal to 5 times 7 is 35. And so now this is a fairly straightforward inequality. We would just add 70 to both sides. And now we have negative 6x is less than or equal to 105. Divide both sides by negative 6. And when I divide an inequality by negative 6, I have to flip the inequality over. This gives me x is greater than or equal to negative 17.5. Go ahead and double check that in your calculator. Since my original inequality was given to me with fractions, decimals, and integers, it is perfectly fine to leave the solution as this decimal. Let's look at example 2. Again, we have fractions and decimals here. I could multiply everything by 4 here, and that would clear all the denominators. It would probably also get rid of those decimals, so let's go ahead and see what happens. I'm going to multiply both sides by 4. Again, doesn't change the inequality statement when I solve it. The 3/4 will reduce to just 3x. I'm going to take negative 5.5 and multiply it by 4. I'll have negative 22. I'm also going to multiply the 22.5 by 4, and that gives me 90 on the right side. Okay, so we have 3x minus 22 is greater than 90, so we need to isolate that x. I'm going to add 22 to both sides. So after I add 22 to both sides, I have 3x is greater than 112. 3x greater than 112. 112 divided by 3. Let's go ahead and check that to see if it reduces in any way. And it doesn't. It's 37.333 repeating. Now, what I know about 0.3 repeating is that it's equal to 1/3. So we could just leave it in the form 112 over 3. You are welcome to do a decimal approximation, but since it is a repeating decimal, it's best to just leave it as a reduced fraction. Let's look at example 3. We have negative 3/7 x plus 10/7 x plus 1 is greater than or equal to 0. We can add them together because they have the same denominator, so that's helpful. Let's go ahead and do that. We have negative 3/7 x plus 10/7 x. That would be 7/7 x plus 1 is greater than or equal to 0. Now we can isolate the x term by subtracting 1 from both sides. Now we have x, because 7 over 7 is just 1. So we have x is greater than or equal to -1. That is my answer. Not supposed to be tricky, just reminding you of all the rules of fractions. In example 4, we have 8/11 x minus 5 is greater than negative 17/11 x minus 14. So we're going to bring all the x terms to the left side. This negative 17/11 x needs to come to the other side. So I'm going to add 17/11 x to both sides. And you might be wondering, Sarah, why didn't you just get rid of the 11 in the denominator first? And I totally could have done that. The reason I am not, just like example 3, was because the denominators match. And so that's helpful when we're trying to combine fractions. This gives me 17/11 plus 8/11, which is 25/11 x minus 5 is greater than -14. I'm going to go ahead and add 5 to both sides. And notice that when I do that, I have all the x terms on one side and all the constant, just numbers, on the other. I now have 25 over 11x is greater than -9. And now, hopefully you remember the rules for multiplying by reciprocal numbers. If we wanted to clear the fraction associated with the x here, we'd multiply by the reciprocal, which would give us 1x. But if we do that to one side, we have to do that to the other side as well. And we have x is greater than -99 over 25. And I know that is not going to reduce. Since this was given to us as a fraction, we need to give the answer back as a fraction. If it had been a mix of fractions and decimals, you could literally pick which one you wanted. Let's take a look at example 5. We have 7.3x minus 2.25x plus 14 is less than 8.45x minus 19.5. And as you can see, these are all decimals, so we will answer the inequality as a decimal if it doesn't come out as a nice whole integer. Let's go ahead and bring all the terms with x to one side and all the whole numbers to the other side, or just numbers to the other side. So we'll have 7.3x minus 2.25x minus 8.45x is less than negative 19.5 minus 14. And now we can combine all the terms on the left. We have 7.3 minus 2.25 minus 8.45, and we get negative 3.4 x, and that is less than, now let's go ahead and combine everything on the right side, negative 19.5 minus 14 is negative 33.5. Now we will divide both sides by negative 3.4. And we get 9.852941176. We can go ahead and round this. Since we have at most 2 decimals here and 1 decimal on some of them, we're going to round to 1 decimal place. So that would be 9.9. X is going to have to be greater than, because when we divide by a negative, we have to flip the inequality. So x is going to be greater than 9.9. Hopefully this has helped you kind of brush up on your fractions and decimals and solving with inequalities.